Alright, so here we have got questions on the sigma notation. Right? I just need to emphasize to you that the sigma notation, it is all about the series. Okay? The sigma notation is part of the concept of the series. So we did the arithmetic series, the geometric series. The sigma notation is a shortcut way of writing a series. Okay? Because most learners, they get to grade 12 doing pure maths, do the sigma notation, they don't understand what it is all about. The sigma notation is a shortcut notation used to represent a series. Okay? Because when you write a series, you can have many terms. You can have a million terms, a billion terms, and so on. Now, we don't have the time to write all of them one by one plus the next, and so on, up to. However, the total number will be. Okay? So, just write it in shortcut form. The sigma notation is part of the series concept. Right? So, the first question, I'm going to do A1. Okay, that's the first question I gave you as homework. So, we're given sigma from k equal to 1 up to 50 of 3k plus 1. Right? Now, you need to know that if you are given the sigma notation like this expression here is the general term of the sequence which is related to that series. So, as you can see here, the k is not an exponent, therefore that's an arithmetic sequence. This is the general term of an arithmetic sequence. Therefore, we are dealing with an arithmetic series. Okay? Then, when we want to determine the terms in that series, we need to know what is first term, second term. So we substitute the values of k starting from 1, that is k equal to 1, up to k equal to 50. Okay? Now, because we are starting from k equal to 1, it means that the sum, or rather the number of terms of this series is going to be 50 because we are starting from k equal to 1. Okay? If we're starting from k equal to 0, the number of terms will be 50 plus 1. If we're starting, say, from k equal to 2, the number of terms will be 49. Alright? So I want you to just add this somewhere in your book. So with the sigma notation, okay, just add this somewhere. Right? We have the bottom, which is more like the k equal to 1, and then we have the top, which is like our 50. Then obviously you have your general term. Right? Your general term. So if you want to know the number of terms in that series, your n for the series will be equal to top minus bottom plus 1. Okay? Very important for you to know that. Okay? Now you can use that formula if you can get confused. But this is very straightforward. If you practice, you'll be able to get it. The only way is to practice. So here, I just need to expand to 3 terms. I don't have to write all 50 terms. So if I substitute k equal to 1, I'm going to get a 4. Because 3 times 1 is a 3. 3 plus 1 gives you a 4. Plus, if I substitute k equal to 2, 2 times 3 is a 6. 6 plus 1 gives you a 7. Right? If I substitute k equal to 3, 3 times 2 is 3 times 3 is a 9. 9 plus 1 is 10. Yeah, but you need to look at what I'm doing. You didn't do the homework. Right? So So we substitute k equal to 3. So 3 times 3 gives you a 9 plus 1, you get a 10. Now we only need the first 3 terms. So this is called expansion of the sigma notation. What I've done there, that's the expansion. Okay? Generally, just determine or write the first what? 3 terms. Right? Then from these 3 terms, I'm going to determine the common difference. Right? 7 minus 4 is a 3. 10 minus 7 is a 3. So I now know that my first term is 4, my common difference is a 3. Right? Therefore, I can use the formula for the sum of an arithmetic series. Yes? The what? Yeah. Yeah, it's a D. From grade 10. That's from grade 10. Okay? Right. So let's find the sum. Okay. I expect everyone, if you did not do the homework, I expect you to copy this down and you must write corrections in your book if you didn't get it right. And you do that quickly, you don't have to spend too long to just write the sigma notation and then write that. In less than a minute, you should be able to do that. All right, so I've got my series there. So here, my A is 4, D is 3, and my N is what? 15. So I can use this formula Sn is equal to n over 2 times 2a plus n minus 1 times d. Right? Please, this formula, we use it when you want to determine the sum of an arithmetic series. So we have 50 terms, so S50 will be 50 divided by 2 times, in this case our A is a 4, plus 50 minus 1 times D, which is 3. Please, I don't want to remind someone that you need to pick 5. Okay? Then you simplify this. You get 25 times 8. So that will be 49 times 3. So that will be 147. Right? Yeah, because 40 times 3 is 120. 9 times 3 is 27. So this will be 147. Right? So this will be the same as 28 times 155. What answer did you get? 3,000?
Wait, it's 25. 3,875. Oh, it's 25. Yeah, but also still good.
So this is the 25. So that will be 155. What answer did you get?
3,875.
3,825.
75.
75. Alright. So we've got that. Right. Because you just use the calculator there, and then you are done. So I'm sure you can see the way that I'm doing the sum. The layout. Okay? This is how you're supposed to do it. The way you do it must be as clear as possible. Okay? You cannot run away from the series. It will be there in your final paper in November. It will be there. You cannot run away from the sigma notation. It will be there. Okay? Those of you who think maybe it's not important now, don't worry to buy it later on. And I also need you to be aware that passing maths, I think I told you that before, it's a game changer. among all the subjects that you are doing, there's one subject which, if you pass, it's a game changer. It's my subject. Okay. All right. If you pass maths, you can choose if you pass with a good mark, you can choose the university you want to go to. If the university wants you, you tell, okay, I don't want to come to university. You choose. All right. What? No, you see, this is the five that I wrote. The issue is about the pen. Yeah, the pen sometimes the pen itself it's not that easy to write with. Okay. Especially if I'm rushing. Right? Okay. Right. Let me carry on. Let me carry on. So the next question is question 6. Now I'm sure you can see that for question 6, the exponent here is a k. K is an exponent. Therefore, we are dealing with a geometric series. Okay? That's a geometric what? Series. Right? So it's sigma from k equal to 1 over half. Right? So let me go to a new page. So let me do it from here. So we are doing this one here. Right? Can I have your attention, please? So number 6, with sigma from k equal to 1 up to 8 of a half to the power of k. So I'll expand first. Okay? Expand to what? 3/10. So if I substitute k equal to 1, I'll get a half. Plus, if I substitute k equal to 2, use a calculator too. You see, she's busy copying down the notes that I introduced yesterday. Instead of doing this, she didn't do the homework. Now, when I'm doing the homework, you are doing something else. You want to do the opposite. Why? Why did you catch up yesterday? What was the answer? Okay, 255 over 255 over 256. Did you all listen? Can I have your attention? I doubt that you should get a negative answer because a half to the power of 8 is very, very small. It's smaller than 1. So inside the bracket, you get a negative. And the denominator is negative, so the answer has to be positive.
So, why, like, am I getting like two different numbers to the ratio?
Where is your calculator? What is a quarter divided by a half? 1 over 8 divided by a quarter. Put it in the calculator. 1 over 8 divided by a half. Sorry, divided by a quarter. It's a half. Okay? 1/8 is half of a quarter. Okay? You don't even need a calculator for that as well. Right? So make sure you are aware of this. Okay, can I have your attention? Please take note here in this question. This is very, very small. It's smaller than 1. Okay? In actual fact, 1 over 2 to the power of 8. What is 2 to the power of 8? Remember, 2 to the power of 5 is 36. It's what? 256. So you are going to add 1 over 256 minus 1. It will give you a negative answer. Okay? Then in the denominator, you also have a half minus 1. That's another negative. So the two negatives cancel out. Eventually, the answer has to be what? A positive. Okay? Alright? Now, you also have to be a guru of your calculator, by the way. Remember, you need to be a guru of your own calculator. Number 7. Right? So we are now doing number 7. We are now doing number 7. So number 7, we have sigma from K. Just copy this down. What about the previous page? You copy down, please. Okay. You know why you end up writing slowly? If you hold the pen five fingers, the chances are high that you are slow, right? If you hold the pen with 5 fingers, the chances are very high that you will be slow, right? Otherwise, you're always sleeping. See this one here, A class. So early in the morning, first lesson, he's feeling very, very sleepy. No, it's very easy to see the face of a person. You see him, but he's alive. You see him. But you are like this. You see the way he's laughing. He's alive. You see her, she's laughing the way she's laughing. She's alive. Alright, let's get on. Let's get on. Okay, do something. Sometimes, alright, you know, as you get older, okay, you start to realize that you wish probably you were younger. You understand? You understand? So when you are this age, okay, everything you do, give it your best shot. If you are in the class, give it your best shot. If you are doing sports, give it your best shot. Be like a sniper. You know, have you ever watched movies of snipers? Yes. Right. Does a sniper shoot to injure or shoot to kill? Kill. Yeah. So at this age, whatever you do, kill it. All right. If you start talking, I'm going to assume that you have copied the work. Okay? Some of you, I don't know how you learn math. You are just sitting. You didn't do the homework. The teacher is going over the homework. You are just sitting. Please, don't cause the pass rate of the school to go down because of you. Okay? Because of your laziness. Okay? All right. Let me carry on. Why are you taking so long to copy this down? That's why I stopped. I did one example on sigma. Don't talk about those questions. Maybe I can call it extra weight because I did that last year. Okay, I'm changing some of the questions this year, but some of the stuff I'm not changing because it's exactly the what? The same stuff. It doesn't change. The sigma notation, how I told it last year, the previous year is still the same. So you realize that, of course, I can change a few things in terms of the questions and stuff, but the content is still the same. That's why it's easy to pass sometimes. All right. So we are now going to number 11. Right? Number 11. Right. Please, I want you to be aware that even if I don't finish going over all the questions today, right? Tomorrow you're writing the investigation. Thursday I can conclude. Yes. 50. The total marks of the investigation. Hey, listen. Can I have your attention? Can I can I have your attention, please? Please, it's not a test. It's an investigation. What that means is some of the questions are so easy. You'll see tomorrow. Some of the questions are so easy. If you just know your basics in terms of your grade 11 trick, that's why I didn't want to tell you that go over this part of grade 11 trick. You need to know the reduction formula. Obviously, you have to know your identities, trig ratios from grade 10. You have to know all that. You understand? You have to know. If we talk about grade 11, it means know your reduction, know your identities. Sine squared theta is got cos squared theta plus 1. Tan theta is got sine theta over cos. Those are basic things that if you are in grade 12, you are expected to what? You don't need the teacher to tell you that you must know your identities when you did grade 11. Unless you skip the grade 11.
You guys say now identities, but in that case, it's not going to be identity. You're going to have to go.
Okay.
And then you'll fail.
Why? Okay. What I don't understand is, okay, if there are specific aspects that you're supposed to know, right? Let's say maybe I didn't tell you something. Obviously, you need to apply your maths. Maths is also an application subject. You can't just come memorize the identity zone. What if you get a question where you might need to think and apply? You get that. That's obvious. Well, for the 10 mark, to conclude about 12.5%, yes. Okay, can you allow me to carry on? Can you allow me to carry on, please? Okay? I'm sure you can see that it's not difficult. Yeah, it's very easy. Okay. All right. I need to carry on now to the next aspect, next question now, where we are doing the reverse. We don't have the sigma notation. We are given the series. We are supposed to determine to write the question in sigma notation. Now, because of our time, I'll probably do one example, but I'll carry on because I'm going to do all the questions that I did in the homework because I'm concluding the topic now. So Thursday, I'll officially what? Finish. Tomorrow, you write the investigation. Yes. All right. So, okay, we are done. Now we are here. Right. Can you just remind me which question I gave you? Okay. Let's just do these two quickly. Right, so you are given sigma from r equal to 1 up to m. Right, the question says determine the value of m, which is the more likely. the total number of terms. Alright? So 5 to the power of r is equal to 19,530. Alright? So what you do here to determine the value of m, right? M here, it's more like that's the number of terms in that what? In that series. Right? So we need to know what's the first term, what is the common ratio, because this is a geometric series. So the left hand side, I can write it as, if I put r equal to 1, I'll get 5 plus. R equal to 2, I'll get 25. R equal to 3, I'll get 125. Then I'll say plus plus. This is equal to 19,530. Okay? Now, the left hand side, I can simplify it and write it in terms of m. So here, the common ratio will be 25 over 5, which is what? Which is going to be a 5. Right? So R is going to be T2 over T1, which is going to be 25 over 5, and that will give you a 5. This is our first term. Okay? Then the next thing is, since R equal to 1 is my bottom, then M, that M there is my top. If you use this formula, it means that M is going to be the top minus the bottom, right? Plus what? Plus 1. So M here is going to be equal to M, right? So the number of terms is going to be M. Okay, so when I use the formula for the sum of a geometric series, where there is n, in fact, let me change that m there to n. This one here. Oh. Okay, it's not allowing me. But in your book, please don't put m, put n here. Okay, put n there. Alright? It's not allowing me, but I will change it later. Okay, so we write Sm is going to be equal to a times r to the power of m minus 1 over r minus 1. Okay? We want to calculate that m. So what is our total? That Sm. It's 19,530. So 19,530 will be equal to a. Now a is 5. Right? The common ratio is also 5. Okay? To the power of m minus 1 all over. The common ratio is 5, so that will be 5 minus 1. So this will give us 19,530 is equal to 5. Well, I can simplify this and write it as 5 times 5 to the power of m minus 5. This is all over 4. Okay, I've used my knowledge of simplifying equations by removing the brackets in the numerator. Alright? Then, to carry on to solve this, I need to multiply both sides by what? By 4. We are solving equations now. What is 19,530 times 4? Quickly, please. 19,000? 78,000? 120, that will be equal to 5 times 5 to the power of m minus 5. Okay? Well, I need to subtract that minus 5. So if I do the subtraction, or rather, if I add minus 5, if I take this minus 5 to the right, to the left, sorry, I'll get 78, 125. Is going to be equal to 5 times 5 to the power of m. Then, obviously, once you get here, you divide both sides by 5. So we divide both sides by 5. Can someone tell me the answer? What is 78,125 divided by 5? 15,625 will be equal to 5 to the power of m. Alright, now I want you to know that it's very unfortunate that you haven't done the concept of logarithms. Okay? So you can't solve solving exponential equations. Alright, can you wait till you go back to the class? Just clear your desk quickly, but stand aside. Clear your desk quickly. There's no one pass it around. But if you talk and you are a bit loud with Jesus, then I have to say something.
But so you hadn't even started to listen. You were still checking, and you were like,
You were supposed to get ready for the lesson.
no, I was the only one that had my book out of class.
Alright. Can you go to your place and be quiet for a few seconds? Because some of you are coming here, you are a little bit hyperactive, so be silent for a few seconds. Can you be silent, please? Like, good morning, everyone. Right. Can you check out your maths workbook? I need to see the homework I gave you yesterday. Alright, can I have your attention? Can I have your attention? Alright, can I have your attention? Can I have your attention, please? Sorry, girls. Can I have your attention? Right, because of the nature of this class, okay, you're one of the top 2 classes in the grade. It's not always that when I give you homework, I must have gone over that word. As long as you've got some background, you also need to think and apply your maths, right? Yesterday, sometimes you may need just one example to understand a concept, right? I told you that the sigma notation is just a shortcut notation of the series, okay? And we did 2 types of series: arithmetic, geometry. If you are given 100 terms, right, you can't write all of them, say from A plus B plus C and so on, up to the 100th term. No. So we can simplify that by writing it in shortcut form. That shortcut form is called the what? Sigma notation. So your knowledge of the series and the sigma notation, they are related. That's why you have to do the sigma notation after doing arithmetic and geometric series. Okay? Now, because of the nature of this class, I cannot always give you homework of something that probably I would have done a homework on, or rather an example on. But you have some background. I did one example and I explained that you have a background from arithmetic series, geometric series, arithmetic sequence, geometric sequence. Unless if you have not been practicing. But if you are practicing, then you should have that background. All right? So I'll go over those questions. And also the other thing is, there is nothing wrong with you getting stuck. Okay? There's nothing wrong with it. Okay? Sometimes you have to learn from struggling. It's a good thing to struggle. Okay? And if I give you a question, especially those of you whom I've never taught before, because the bulk of you I never taught you in the past. When Mr. Chiponda gives you homework, he goes over every question by question. I'll never skip any question. In fact, as long as I give you his homework, I'll go over. Okay? So you don't have to stress yourself. Okay? So I'm going to go over every question by question. If you've got anything that you feel that maybe you need clarity on, I'll clarify. Okay? All right. So the first question was A1. Right? Now, before I go over this, I just want to repeat this again. The sigma notation is a shortcut notation of the series. And there are only 2 types: arithmetic, geometry. Okay? It's just a shortcut way of writing a series. Okay? Now, for A1, we are given sigma from k equal to 1 up to 50. Right? Now, the question is, how many terms do we have in that series? Right? So if you want to know the total number of terms, you need to memorize this formula. So if I give you a sigma notation, we have the bottom and we've got the top. Right? If you want to know the number of terms, the number of terms n will always be equal to the top minus the bottom plus 1. Please make sure you write this somewhere in your book. Right? Make sure you know this. Okay? The number of terms is equal to the top minus the bottom plus 1. Okay, so here we have k equal to 1 and the top is 50. So our number of terms will be 50 minus 1 plus 1, which is 50. Okay? Are you following? If 50 minus 1 plus 1, that's equal to n, the number of what? Of terms. And this gives you what? 50. If you want, you can use your fingers to start from k equal to 1 up to k equal to 50, you get 50. But the best way is just to memorize that formula which I wrote for you. It's also in your textbook as well. All right? Now, if you want to find the sum of these 50 terms, you have to expand the sigma notation. By expand, we mean substitute the values of k. Only 3 values are fine. Just substitute 3 so that you can determine the first term, the second, and the third term. Alright? So if I substitute k equal to 1, 3 times 1 is a 3, plus 1 you get a 4. K equal to 2, 3 times 2 is a 6, plus 1 you get a 7. K equal to 3, substitute here, 3 times 3, 9, plus 1 you get 10. Now, because the series has got 50 terms, we don't have all the time to write all 50 terms. So we just need 3. Then you put dot, dot, dot. Now, the dots represent the fact that there are other terms after the third term. Okay? Then, also from this sigma notation, you need to know that to the right of the sigma notation, sorry, can you tell her to sit straight and pay attention? Right? This expression here is called the general term. So when you see the sigma notation, be aware that on the right-hand side of the sigma notation, there will be a general term of the sequence. And your 2 sequences you did, that can be written as a series, are arithmetic and geometric. Now, this k here is not an exponent. Therefore, the series is arithmetic. If the k was an exponent, then it would be a geometric series. So this is the general term of a linear or an arithmetic pattern. Okay? So we have our first term, a, then we can calculate the common difference. 7 minus 4 is a 3, 10 minus 7 is a 3. So we now have the first term and the common difference d. Also, our number of terms, they are equal to what? 50. Then you write your formula for the sum of an arithmetic series. Sn equal to n over 2 times 2a plus n minus 1 times d. Always write the formula first before you substitute, because there are times when the formula can be awarded a mark. So Sn equal to n over 2 times 2a plus n minus 1 times d. Right? Then you substitute. Where there is n, you put 50. Okay? Where there is a, you put 4. Where there is d, you put 3. The rest is just simplification, which is not grade 12. Yes.
So when you just go to the answer and you need to show those two steps.
Well, you see, because I don't teach with a calculator, I'm sure you've seen since you came to my class. Right? So, because I do this without a calculator, that's why I show this step and that step. But since you guys will be having a calculator, you can move from here to the final answer. Yes.
So, since we have the last class on arithmetic equals, here we just do the formula n over 2 over bracket plus L.
No. Don't confuse the value of the last term and the number of terms. The number of terms here is going to be 50. Unless you decide to substitute k equal to 50, then you determine the value of the last term. You can do that. Okay. Are you following what you're talking about here? You can substitute k equal to 50 into this general term so that you can calculate the last term of that series. Then you use the last term and the first term to calculate the sum. Okay, let's do it. Let's do it. Please be aware that when I teach this class, I don't teach it like I'm teaching a green class. Okay? Do you understand that? There are some things that I don't talk about in a green group class. There are some things that I do with this class that I don't do with the green group. So be aware of it. All right. Okay. Okay. So we are saying, let's calculate the last term. Right? So if you substitute k equal to 50, it's going to be 3 times 50 plus 1. And that will give you 151. We know our first term, it's a what? It's a 4. Okay? That's a 4 there. Right? So we have got the last term, it's 151, and the first term is a 4. So we can use the formula Sn equal to n over 2 times a plus l. All right? Are you following that? What is your network? Right, so this will be S50 is equal to, our total number of terms is 50 over 2 times the first term, that's 4, plus the last term, that's 151. So this will give you 25 times 155. Okay, now check this. We have got 25 here times 155. And here we've got 25 times 155. So you get the same answer. Okay, so that will be 3,875. Okay, so for this question, you had 2 ways of doing the question. Is there anybody who has got a question? Thank you so much, Jen, for talking about that. Right, at least I provided some clarity there. Okay, is there anybody who has got any questions so far? Before I move on to the second question. So, just to summarize the sigma notation. A sigma notation is a shortcut form of a series. Okay? So don't get confused. You see, the sigma means that you're talking about a series. And you are only taught 2 types of series: arithmetic, geometry. That's it. There is no need for you to let your mind wander around. What is the sigma about? It's about a series. It's a shortcut way. Okay? Like how we can maybe write your first name and your surname using the first letters of both the name and the surname. Okay? Someone like, hey, she's Celine Maibek, so I can call her CM. Okay? Yes, in this class I can call her CM. Okay? So this CM is instead of me writing Celine Maibek, I can just call it what? CM. So the sigma notation is a shortcut for the series. And there are only 2 types of series that you were taught: arithmetic, geometry. Okay. Right, let's move on to the next one. Now, the next question was number 6. But I also want you to be aware that I might not be able to finish all the questions. I'll continue on Thursday. Okay? I'm not going to start geometry until I finish everything on sigma notation. So I'll go over all the questions. Right? Tomorrow we won't be able to have a normal lesson because of writing the investigation, but I'll carry on from where I stopped today. Yeah, that's part of tree. It's part of tree. It's out of 50. It's out of 50. All right. Let me warn you before I carry on. If you intend to get a distinction in maths, you have to be a master of your trick. If you intend to get a V in maths, you have to be a master of your trick. Because trig contributes the largest percentage in maths paper 2. It's the most important topic in grade 12 maths. There is no other topic in paper 1 and 2 which contributes so much of marks than trig. That's why we are giving you an investigation on trig. Also, you write an assignment in grade 11 trig as well. Okay? So that by the time you get to the trials, you are well prepared for that. Okay. All right. Let me carry on. But there's no one here who can get a distinction without trig. It's not possible. Okay. All right. Let me carry on. So number 6. Number 6, you have sigma from k equal to 1 up to 8. Now, for this question, you can calculate the sum manually because we only have 8 terms. So we just substitute, okay, k equal to 1. I'm sure you can see that this k here, it's an exponent. Okay? Since this k is an exponent, what's happening? Okay, since this k is an exponent, it means we are dealing with a geometric sequence or geometric series. The k is an exponent. Remember, the first day that I introduced the geometric sequence, I told you that it's also called the exponential sequence. Remember that, right? So, if you substitute k equal to 1, you get a half to the power of 1, which is a half. K equal to 2, half squared is a quarter. K equal to 3, half cubed is 1 over 8. Now, I don't want to expand all of them, okay, but you can because the number of terms here is just 8 of them. So you can write all of them, then you add them, you get your sum. But I want to use the formula, so I decided to just write 3 or just expand to 3 terms. So I have my first term, then I calculate the common ratio, it's T2 over T1, which is a quarter divided by a half. And that will give you a final answer as a half. Okay, so the common ratio is a half. The first term is a half. Okay, then you move on to use the formula of a finite geometric series. Why do we have to use this formula? Based on the sigma. Can someone give us an explanation as to why from this sigma we have to use this formula? Okay, it's geometric. What else? No. Sorry? Thank you. Thank you. Right? The main reason why we have to use this formula here is number 1, it's a geometric series. Also because the number of terms is given. Number of terms is given. From k equal to 1 up to 8, that's 8 terms. So it's not an infinite series, it's a finite series. Please remember, there are two types of series. A finite series where you know the number of terms, and infinite series where you don't know the number of terms. So here, we know the number of terms. Therefore, we are dealing with a finite geometric series. Hence, we have to use this formula. Sn equal to A times r to the power of n minus 1 over r minus 1. Okay? Then we substitute our A, our R, our N, simplify, you will get that 255 over 256. So if you did the homework, mark your work. Okay? Mark your work. Alright? Is there anybody who has got any question? Huh? Anyone who has got a question? Okay. Then let's carry on. The next question is number 7. Now, number 7, we have sigma from k equal to 2. You know what? I don't understand why someone who is 17 or so, I think you age you're 17,
18.
some are 18. Why some of you lose concentration?
Some of the 05.
What? Okay, Diane, I'm talking about concentration. Because when I'm standing in front of you, I can tell you who is paying attention and who is not. Okay? We are doing a detailed discussion of the homework. So you need to pay attention. You were given an opportunity to do the question, right? So it's now an opportunity for us to go over those questions thoroughly, so that if you had issues, those issues can be resolved. Right? So pay attention. You've never seen me losing concentration since you came to my class. Okay? You never saw me losing concentration. Alright, number 7, sigma from k equal to 2 up to infinity. Okay? Of 8 over 4 to the power of k. Remember, this is a general term of a geometric sequence. Make sure you understand that. The expression to the right-hand side of the sigma notation is just the general term. Okay? Since k is an exponent, then it's a geometric series. The whole question is on the geometric series. And a geometric series, together with its geometric sequence, they are related. Yes. Yes. If you see an exponent and a sigma, that's a geometric series. But then we have this infinity on top of the sigma. That's a clue that you are dealing with sum to infinity. We don't know the total number of terms. So if you try to use this formula n equal to top minus bottom plus 1, you won't be able to determine the total number of terms, because you end up having infinity there minus, in this case it will be minus 2 plus 1. Okay? Which means you end up getting n equal to infinity minus 1. And infinity is not an exact value. Therefore, this question is on sum to infinity, but I need to prove that it is really true. So, substitute k equal to 2. For this question, you just start from k equal to 2. It's not always that you start from maybe k equal to 1, always no. Okay? So k equal to 2, you get 4 squared in the denominator. 4 squared is 16. So 8 over 16 gives you a half. K equal to 3, 4 cubed is 64. 8 divided by 64 is 1 over 8. 4 to the power of 4 gives you what? It will be 256. So 8 divided by 256 gives you 1 over 32. Now, I just want 3 terms. So I've expanded to 3 terms. So I know my first term. Now I need to determine the common ratio. So the common ratio T2 over T1 will give me a quarter. All right? Since the common ratio is between -1 and 1, it means we are dealing with an infinite geometric convergent series. Therefore, to calculate the sum, we have to use the sum to infinity formula. We only use this formula when the common ratio is between -1 and 1. That needs to sink into your blood and it must flow everywhere inside you.
Sir, what happens if it doesn't need that?
Then you are not dealing with a convergent series which is infinite.
Okay, what do we do?
Well, generally because you are only in grade 12, all your questions on the geometric series either to be a finite series or it has to involve sum to infinity. So you won't get a question where you don't know the number of terms, but the common ratio is more than 1 and less than -1. No. All right. Is there anybody who's got a question? So you substitute the first term, it's a half, common ratio, it's a quarter, you simplify, you get 2 over 3. It's very simple. And let me warn you, okay, by the way, I hope you all know that passing my subject with a good mark, it's a game changer. All right? Yes, it's a game changer. So if you intend, as I told you the first week of school, that the only person who will make me smile is the person who gets 80% or more. If you get 75, okay, you have passed. It's fine. Okay, everybody's gonna pass, right? So listen, if you intend to get a distinction in math, you have to know your sequences and series as well, because it contributes 25 out of 150 when you write your final exam. 25 marks on sequences and series only. And it's usually, can I have your attention? Can I have your attention? It's usually question 2 and question 3. Okay. All right. Is there anybody who has got any question about this? Any question? All right. If you don't have a question, I hope you can see that I'm getting deeper into each and every question. So you have no excuse after this lesson to end up saying that you do not understand, you don't understand. Well, the issues that you had last night, you struggled with, I'm resolving those issues. Okay? All right, let's move on to the next question. Next question. Number 11. Right? So, number 11, we are given sigma from p equal to 0 up to infinity of 3 to the power 4 minus p. Okay? So here, we are only substituting the p value from 0. Okay? We don't know the number of terms. Okay? The n is not given. So if you put p equal to 0 there, you get 4 minus 0. So 3 to the power 4 is 81. Then put p equal to 1. You get 4 minus 3, 4 minus 1, which is a 3. 3 cubed is 3. Sorry, it's 27 rather. Please, can you stop taking pictures in the class? Okay? Stop taking pictures in the class. There's no need for that. Because there's no other subject besides maths where the teacher sends you a PDF of the work. No other subject. Okay? No, there's no other subject. Which one? Life sciences. All right. Okay. How do they make the PDF? No, you must tell me how. Because, listen. It's very easy to just type out somewhere or take pictures and then put them in a document. That's very easy. Right? All right. That's very easy. All right. Yes. It's very easy. You just copy and paste and then put it in a document. All right. Let me carry on. So we have got our three terms there. Okay? So first term is A, That's 8 to 1. The common ratio is 27 over 8 to 1, which is a third. Okay, so I now know the first term A, the common ratio is a third. Then, since the top there is infinity, okay, and our common ratio is a third, which means the common ratio is between -1 and +1. Therefore, we use the sum to infinity formula. Okay, that's the formula that you're supposed to use. Right? Then you substitute, you simplify, you get that as your answer. Okay? Right? Any question? Okay, when I was moving around checking your work and so on, some of you were saying, I didn't understand. Is it making sense now? Right. Let's get on. Right. Let's move on. All right. The next question, part B. Part B. Part B. So I gave you B2, I think, and there's another question as well. So I'm trying to do all of them before the bell rings. So B2 says sigma from R equal to 1 up to M, okay, of 5 to the power of R is equal to 90,530. Right. The question says determine the value of M. Now, M is going to be the total number of terms in that series. Okay? M will be the total number of terms in that series. Right? So, it may be the total, but for the first one, it will be the total number of terms in the series. Right? So, what do? First, expand the sigma on the left hand side. Just write 3. Okay? Determine 3. Substitute R equal to 1, you get 5. R equal to 2, you get 25. R equal to 3, you get 125 plus plus. There are many terms, and we don't know how many are there. So I just want 3. Then you must equate that to 19,530 because this is the sum of all those terms. Okay? We don't know how many there are, but we need to determine how many of them are in that series. So this is the sum. Okay? Then we know the first term. We know that here R is an exponent, therefore that's a geometric series. Okay? The R is an exponent, therefore this is a geometric series. Then the second term is 25. The common ratio will be T2 over T1, which is a 5. Okay? Alright? Any questions so far? Okay? Then we use the formula for a finite geometric series because we want to calculate the number of terms. So we have to use the formula for a finite geometric series. So that's the formula there. Now, instead of putting n here, put m there. Okay? So the formula becomes Sm equal to that. Then the rest, it's substitution and knowledge of exponents and exponential equations, which is grade 10 and grade 11. Okay? So I substitute Sm. Okay? Then the first term is 5, common ratio is 5, the number of terms is m, common ratio is 5. Well, in this class, I'm not supposed to teach how to solve equations. Right? Okay, let's get on. So, from this step now, okay, you multiply both sides by 4, you get 78,120 is equal to 5 times 5 to the power of n minus 5. Then you take the minus 5 to the left, you will get to this point. Okay? Then you divide both sides by 5 because these two have got this 5 here. Then you come to this exponential equation. Now, to solve this exponential equation, so far, you only have one technique that you can use. That is making the bases the same on both sides. So convert the 15,625 to a base of 5. And that will be 5 to the power of 6. Okay? Therefore, m will be what? 6. Okay? Later, in term 2, we'll do what are called logarithms. That can also be solved using logarithms. But that's for term 2 now. Right? After term 2, you can solve it using logarithms. Okay? Any question?
What if you multiply 5 and then you just said 5 and then 1, 5 what you say?
What is what?
You said 5.
This 5 here.
Yeah. Wait, time to 4. Never mind, I can block it.
No, it's not time. This is the denominator of that.
No, I said, you just said 5 to the power of m plus 1. I'm going to say,
In the numerator of denominator.
yeah. 5 to the power of m plus 1.
5 to the power of m plus 1.
Minus 5. Same figure.
Why would you have to go as 5? Let's not complicate it. Yes, eliminate the denominator by multiplying both sides by 4. Take the minus 5 to the left. Get to that point. Yeah. There is no need to complicate things. Alright. Listen. Can I have your attention? Can I have your attention? Can someone tell me the next question that I asked you? It's what? It's B3. Okay. Now, it's your responsibility. Wait. You need to wait. Wait. Right? So, can you please carry on from here? Right? You create a quadratic what? Equation. And solve it. It's not because you can see that confusing the M and the N, they are different, right? But there are times when the two are
But it's actual.
the first one.
Yeah.
Don't make it on like that.
No.
Put in mind, it's supposed to be Generally, there are two types of questions on the signal. They can give you a series, right? And you can ask to write in sigma. Or you can get a question like this, where the sigma question is then you ask the question from it. Those are the 2 ways of doing it.
What exactly are we supposed to do tomorrow? Like, I'm confused because from the breakdown that you gave us, it has analytical geometry.
Yeah, it's only the distant formula. Remember, I never said learn analytical geometry. I said distance what? Formula. So you need just to remember your distance formula.
Okay, so this formula is
Reduction,
reduction
trig ratios from grade 10. Sine theta is opposite over hypotenuse. Tan theta is opposite over adjacent.
Yes.
Yeah, that's what. And your special angles.
So wait, what about compound angles? Do you have to learn that?
The investigation is on compound angles. Okay, so if you want to learn about the compound angles, you can also learn if you want.
Is it necessary?
But you see, what will happen is the investigation will guide you as to how you end up coming up with the compound angles. So if you go over them on your own, you might get confused. But if you want, you can.
So I think, do you have anything, like any worksheets or something I could use to study for it?
There's no worksheet for it.
So how does this?
Can you stop stressing? Do you remember your grade level?
Yes, a bit. I have my grade 11 book.
Yes, then go over those basics. It's not a test.
So with the reduction formulas and everything, we learn all of them. Because there's like so many.
Okay, in any case, listen, you are in medicine, you are expected to know the reduction formula.
So you must know all of them.
Okay, some of them may not be applicable to the investigation, but it is better for you to know.
I mean, so I want an A, and yes, sir, we want to make you proud. We take all the A's.
Yeah.
But then it's hard.
It's not hard. Please be positive.
Okay.
The investigation is not hard. Some of the questions are so easy, you see them tomorrow. They are not that challenging. If you know your basics, like what I told you about, you shouldn't have any problem.
So do you excellent?
I have a yes. But I charge a lot of money. I'm not cheap because the knowledge that I share, I consider it to be unique. Therefore, I'm not cheap. But if you want, you can talk to me and then we can see. Like from here, the form ends there. Then you can do that. If you want, you are serious, then you can.
Yes, sir. Where and how and where? Okay, I'm actually.
Like, come and see me in second grade.
I have duty.
You have duty.
Okay, I'll come in. She's like, yeah.
Come and see me.
Okay.
You just talk for a minute or two, then you can go. See you? This is very nice. You're supposed to be better to Piano. Yeah. Piano is in charge of the videos in mind. You are really chatting.